Now comes Mr. Andreas Faul. For those who don't know him, without him we wouldn't have the EcoPaperLoop project in the way it is, and we wouldn't have Engede the way it is. He's Mr. ISO standards, Mr. Paper recycling technology, Mr. everywhere and everything. And even twice today, he starts with his own presentations, later to give another one, and his first presentation deals with the Deinkability of graphic products. What else? With news and results of the Deinkability testing that we frequently do with Engede. We do that together with customers. We do that together with the printing industries, with printing ink manufacturers to see what kind of inks perform better than others. And I think now you're ready to go. The floor is yours.
Thank you, Axel. You raised the expectations quite high. I hope that I can fulfill it. Yeah. Okay, yeah, we'll talk first about the inking and the inkability. Just for those of you who are not as familiar with that as I obviously am, according to Axel, why do we need to de-ink? When you look at this newspaper reader here, he hopefully recycles in a good manner, or collects, brings it to collection, and then it's recycled in a plant that somehow, no, it's too weak, okay. Okay. Yeah, it's recycled in a process, made to new paper again, sent to the printing machine, and then back as a new newspaper. And the de-inking, the removal of the printing ink in order to have a bright paper again, happens down in the center in the so-called de-inking plant. The process works according to that very rough overview. You have a pulping stage, usually a vat or a drum pulper, which defibers, slushes the paper, and you get a pulp which still contains all the impurities and the ink, so it's rather dark and gray. Then you do some mechanical screening through holes and slotted baskets and centrifugal forces, and then you get at least a cleaner sheet of paper, a cleaner pulp, but still with all the ink in it. And then you have flotation cells, which look as you see it from the picture up there, which remove the detached ink, and then you end up with a rather bright pulp sheet then, from which you can make new paper out of it. The de-inking cell itself looks like this. There you have the diluted pulp is there is air injected in this pulp, and this air builds a foam together with the soap which is in it, and this foam attracts the ink, if it's hydrophobic, and moves it to the surface, and there it can overflow, and that will give a sludge which is then further treated. So this is a picture through one of these slits at the top where you see the foam overflowing. It's a two-stage process, the inking. The first is that you have to detach the inks from the fibers, and the second is that you have to remove the inks, usually by this flotation, as I just showed you. There are some certain cases where wash de-inking takes place as well, but the predominant procedure is flotation de-inking. That has some preconditions to work, and they need solid particles, so the ink cannot be as a soluble dye, it has to remain as a particle, and it needs a certain size range. You usually say between 10 and 100 microns. The particles have to be hydrophobic, and you need the proper chemistry, which is somehow detergent-like with soap and caustic and some bleaching agent and so on. And the technology has an operating window, which is shown here in the center as the green area, And the process was developed mainly to remove the old letterpress inks, which are not on this slide anymore, but the predominant printing technology, offset and rotograver. There it really works fine. When you look at dry toners, they are not an issue as well. But when you go more to the side, to the left side, you have small particles, usually water-based. In flexo printing, what we heard from Daniele already on this life cycle analysis, and in inkjet, which we cannot remove by flotation, there are some activities going on, mainly in inkjet nowadays, to improve the situation. Therefore, the newer inkjet is already moving to the green area, and I will show you some results later on. On the other side, where you have large particles, usually cross-linked, where you find liquid toner, at least from one supplier, and UV-cured systems, which tend to form large particles, not easy to detach from the fibers, and therefore not removable in flotation. To illustrate that, what you just have seen here, some hand sheets, some laboratory sheets. On the left side, again, the small particles which cannot be removed. This example shows some flexo newspapers. In the center, you'll see a good deinkable offset newspaper, and on the right, you see some cross-linked systems, old newspapers, where the inks are really cross-linked together, or an UV print on the lower right part of the slide. There was an activity going on to assess this deinkability, to make this result, what you just saw, bring it into figures. There is a method, that's Ingede method 11, which simulates the basic de-inking steps in laboratory scale, and you get some results out of it. When you treat a newspaper, a magazine, any other print product with this method, you get 3 quality parameters. It's basically brightness, cleanliness, and the color. And then we also get 2, let's say, auxiliary process parameters, which is the degree of ink removal and the coloration of the process water. And then this is converted to a score system. Here are some details, what I just told you, that you have threshold values, you have target values for each parameter, and exceeding or being better than the target means you get a full score for that parameter. Being below the threshold, that means that the product fails. And yeah, that's basically this assessment. We installed the first version of that in 2008 in the European Recovered Paper Council, the ERPC, and just recently made a revision. Which was not revised was this general assessment that if you get more than 70 points, the deinkability is rated as good, and then fair, tolerable, or then if it's one parameter is negative, the product fails. So what was the revision of the scorecard, which was just adapted a few weeks ago? We have the yield as a boundary condition, and due to, let's say, not optimum assessment of coated products, we said, okay, the fiber yield is a determining parameter. So the test has to run in a way that at least 65% fiber yield is achieved. We have in the category in the product category with low ink coverage, we have a certain had a certain luminosity value to distinguish between two subcategories. We replaced that by brightness because it's a more usual parameter. In that top product group, product category, we lowered the target value from 90 to 80 points of luminosity, but on the other hand, we increased the threshold from 47 to 67 because products with low ink coverage and being printed on a wood-free paper, they usually end up in high grades of paper for recycling, and these high grades are bought by mills which have higher brightness requirements, and they pay more for that paper for recycling. So in order to be more according to the market, we increased the threshold here. There was this distinction between magazine, which means a high ink coverage, and the former called stationary products with a low ink coverage was not optimum, so we improved that, and we also installed a measuring of the mean gray value of the product, just in case there are doubts how you should assess it as a magazine or as a low ink coverage product. Then there is one disadvantage of the method, that when you have a very low ink coverage, the ink elimination gets wrong because of the measuring testing technique. We defined how to assess those. Then in those cases, the ink elimination will not count as one of the excluding parameters. We changed something in the reporting to make that clearer, and we are in the process of exempting certain print products for which we know from the ink recipe, from the ink and paper combination, that they are good deinkable, that they do not need any testing, for example, to achieve an eco-label. That was a wish of the printing industry, which feared that they will have very high costs when applying for an eco-label, that we say, okay, it's no need to, when we know from the ink composition and from the paper that it will pass, to make an extra test. But we are working on that still. We have lots of tests as a database. Within EcoPaperLoop, we tested about 80 newspapers and magazines in the last 2 years, and they are from the partner countries. And we combined those results together with the ones from Ingede, with about 470 entries in the database of all categories of print products, which started in 2005 and it's still ongoing. And before the EcoPaperLoop project, these were mainly from northern, southern, and western part of Europe, and some occasional tests from Japan and from the USA. So here I give you some results on the testing by product category. So starting with offset newspapers, the column on the left is the average from the Ingede database, and the other blocks of data are the new tests within the EcoPaperLoop project in the different countries. And on the top right, you see that pie chart where you see which portion of the whole tests, including the Ingede tests, have a good result, a fair result, tolerable, or how many failed. So it's about 80% of the newspapers which passed the test, the offset newspapers. Then we have uncoated magazines, same system here. On the left, the Ingede average of the Ingede database, and then the EcoPaperLoop partner countries, and on the top right, the general assessment with also 80, maybe 85% positive results. Then the coated magazines, we have some, in offset we have some failing, most probably due to UV cured covers. If not, then the result, as you see, is usually very good in the 90s with only one exception here. Then we have the rotograver magazines, the uncoated ones, no problem so far, and also with about 90% positive results. And the rotograver coated, even better, 95%, not a single one failed. And there we have, of course, rotograver is just usual in Germany and Italy from the partner countries, so we did get those samples only from these countries. Then a general overview, which was not a major part here in the EcoPaperLoop project, that we have a general overview of the Deinkability by the printing technologies. So here we have the average of all products with a success rate of 72%. Here we have the analog printing technologies, offset, rotograver, and flexography, where we did not have many tests. So the top figure shows you the number of tests, and the bottom figure the success rate. So there is 0. Then we have dry toner, we have liquid toner, and we have inkjet on the far right. And I come to those a little more in detail. First, the liquid toner. So far we have tests of 2 different suppliers. One, every single sample failed due to okay, thank you. So every single sample from that one, the tests or also commercial prints we found on the market failed due to dirt specks. And there is a new supplier which has now the first machine on the market, and there we have only results of test prints, no commercial ones yet, which usually passes the test. Then we have inkjet. It's quite a variety of technologies in inkjet. One exotic one with UV cured, which failed, same as UV offset due to dirt specks. Then we have dye-based until here, which usually fail due to luminosity, discoloration, and ink elimination. Then we have the pigment-based inks with occasional quite good results, with having still the luminosity, the ink elimination, and the filtrate darkening, but not the discoloration compared to the dye-based. And then when you go to pigment-based inks, which is this block, what you see here, and you use a special paper, an inkjet paper, then the success rate climbs. And same or even better when you have a paper which is pre-treated before printing. And here some exotics, also some quite exotic things with non-aqueous inks, not water-based inks, which perform also very good. The same data as you saw in the previous picture now as averages, where you see it, these UV cured failing due to dirt specks, the the dye-based, failing due to luminosity, discoloration, and ink elimination. And then in pigment-based, only 70% success rate, but the averages are already above the threshold. And then when you come to the inkjet paper and the pre-treated paper, then you get higher success, and the non-aqueous inks with 100% success rate. And there are 20 products which we could not allocate. So these are only here within this total average, but we cannot say which ink technology that was. Again, the same results, but in a different display by test results. Here, what we get from R&D samples or from samples which we receive for Ecolabel certification, where we have a success rate of 37%. Then we have demo samples, which means those are samples we get at trade exhibitions where the suppliers present their machines and some samples where we collect them and test them in the laboratory. Nearly the same rate, but then when we go to commercial print products, which in inkjet so far we tested newspapers, usually foreign newspapers printed at airports or something like that, so low number of copies each, but they all fail. So it's really on the market, we do not see any deinkable inkjet yet. So again, these figures as averages, there you see that the test category, quite a good average, demo worse, and then the commercial failed. And when you compare that with the good performers, the offset, the rotograver, and the dry toner, you see that even the test, the best of the three groups in inkjet is far below the good performance in the inking. So that shows that there is a lot of development still necessary to get inkjet to the deinkability what the industry needs. Yeah, that brings me to the conclusion that we saw from these tests within the EcoPaperLoop project of newspaper and magazines that there is not a significant difference in the deinkability compared to what we had from our tests in Ingenia. But yeah, we are really concerned about liquid toner and inkjet. Liquid toner because of the many dirt specks from the systems from the market leader, and an inkjet, we just saw it, that even if it's the inkable, the performance is by far not as good as the analogs are. Okay, so we'd like to thank you very much for your attention and be happy to answer your questions.
Thank you very much for the presentation. This has been our battlefield for years, the deinkability of printed products. Mr. Augustin.
Thank you, Joseph Augusta, Austria producer. You said that there are, or showed us that there are quite a lot of new technologies that are not really in favor of us thinkers, so they are not thinkable. Is there any estimation so far how big the market share of these new, not so favorable technologies is in the paper for recycling?
Fortunately, at the moment, the market share is so small that we do not see a major decline in the Deinkability at the moment. But on the other hand, it's a big advantage that we are now in the position to talk to the suppliers to improve the system before it gets a problem. With flexographic newspapers, it was the other way around. First, the under-inkable flexo was on the market, and then the de-inking industry started together and make research and investigations and so on. So here we learned the lesson from the flexo and are pretty active in inkjet even. From the prognosis, we know that inkjet will be will have the best growth rates in the printing technologies. And therefore it's important to talk now to them.
I may add something. It's not just a question about market share. It's because the world is never equal, is never in equilibrium. The only accident that we ever had with one of these new printing technologies was overprint. Yeah, that we had a huge load of photo book overprints with liquid toner in 1 mill. Yeah? It was not evenly distributed, so it's not a question of average, because the world isn't average. Yeah? The world is that one load gets into 1 mill and ruins the complete production there. That was a significant loss there, a damage of more than 150,000 euros, just due to one load of an under-inkable product. Yeah? So this is, it's very dangerous to talk about market shares here.
No, but if it's really growing that market share, then it's a danger for all of us.
Any more questions? So, thank you, Mr. Faul.
Thank you.
Just in order to get rid of this stupid paper band that I have on my hand, it's a reminder that because I forgot some of my housekeeping, it was Mr. Kappen. He's gone already.
No, but he will be back.
He will be back, okay. And the other thing is, as we do not have any more presentations other than English, you can return your headsets if you borrowed one. Please bring it back to the audio guys.